Hello student, today we will start our introductory lecture of distributed DBMS. The full form is Distributed Database Management System. In third semester, we have already learned DBMS, Database Management System. Based on that, another advanced and one of the most important database concept or the subject, it is distributed DBMS. We have to learn in our 7th semester, and its a subject code is 2170714. In this video lecture, you will get basic information about this subject. So what is the prerequisite of this subject, and to understand better knowledge regarding this subject, you have to first clear the basic concept of database management system and networking. From this subject, you will get the introduction and basics of distributed DBMS and its associate problem. So you will be able to understand various algorithms and techniques for managing distributed database. In our syllabus, total theory lecture is 3 and practical hours is 2. So its a credit is 5. Here you can see that it's a 3 lecture, 2 hours practical, and total credit is 5. In final examination, there is 70 marks question paper will be asked, and internally 30 marks will be as a mid-sem taken, and and in external it's a 20 plus 10 and 20 again for the your practical performance, and external viva 30. So it's a total is 150 marks appear for that, and from that whichever the mark will you get, based on that you will get the grade of DDBMS subject. Its a short form is DDBMS. Again I am repeating you, DDBMS means nothing but a distributed database management system, and for the reference purpose you have to refer the book Principle of Distributed Database System. Author name is Otsu, and the publication is Pearson publication. You have to learn total number of 9 unit in a theory portion and 10 practical performance you have to do. First unit name is a introduction, in which we will study the concept basic of distributed database system, distributed data processing, what is distributed database system, promises of DDBMS, complicating factors, problem areas, and total hours is 3 hours based on GTU syllabus, and its a weightage is 7% from the total unit. In this unit we have to understand why we are learning distributed database management system. All we know that in a third semester in a DBMS we have studied the comparison between file system and database management system. So what is the file system? It's a one of the creating procedure, or we can say that in a file we can store the data, and that file will be stored in our system. File processing system, redundancy of data will be happen, duplication can be possible. So consistency cannot be maintained in that file processing system. So we will move on the DBMS concept. In a DBMS concept, different program can run in a different system or different machine, but it's a entire information we are storing at a center place. It's our database, and at the time of requirement we can access those database from the user request, and database will respond as per the need of user. And it's also known as a centralized DBMS. But here we have to understand the distributed database system. So what is the distributed database system? Distributed database is a collection of multiple logically unrelated database distributed over a computer network. That's why we have two knowledge of network as well as database. It's a nothing but a multiple and logically unrelated database distributed over a computer network. Means if we are taking one of the example of four different site 1 location is Junagadh, site 2 location is Rajkot, site 3 location is Ahmedabad, and that different site is accessing the data from different places, and that entire site have its own database, and that all site as connected with the computer network. So it's a kind of work like in a distributed database system. In that also some of the advantage, some of the disadvantage we have to study when we are starting the unit 1 introduction. Then second one is a overview of RDBMS. Here the meaning of R is a relational database management system. In that we have to study three concepts. First concept is basic introduction of RDBMS, then the concept of integrity, and third one is a normalization. Total hour allocated for this unit is 2, and in a exam point of view weightage is 5%. So what is the requirement of this unit is when we are working with the relational tables and we are implementing the relational concept in our database, at that time this concept will very useful. What is integrity? Integrity rules are nothing but are constraints that define consistent state of the database. Remember one more thing I am telling you, that you have to understand the basic word or basic the term which we have already learned in a DBMS, because it's a basic fundamental are taken from that. What is the meaning of consistent state? Means truth state which will give you the correct value or correct state, not the invalid or inconsistent state. So integrity rules are constraints that define consistent state of database. And the concept of normalization, detailed normalization we have already studied in DBMS. It's a first normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form. Likewise we are studying detailed normalization in that. But here just you have to understand the basic concept of normalization. So normalization is nothing but it's a step by step reversible process of replicating a given collection of relation by successive collection, in which relation have a progressively simpler and more regular structure. Relation means nothing but is your database table. And advantage of normalization is to avoid the duplication from our database. So in a second unit we will study these three basic concepts: integrity, normalization, and introduction of RDBMS, means relational database management system. Third unit number, and its name is a distributed DBMS architecture. To study this unit and to understand this unit clearly, you have to clear the diagram or architecture of ANSI Spark architecture, or we can say that view of architecture, conceptual architecture, which we have studied in DBMS. If you have remember, then at the top level user, then second level external schema, third conceptual schema, and last bottom internal schema. When the user request, based on that entirely external view, conceptual view, internal view, and it will give the response to user. This is the architecture of the ANSI Spark that you must have to clear in your mind, in which we have learned the different models: autonomy, distribution, heterogeneity. So what is autonomy? Autonomy refers to the distribution of control, not data. Here the must have to focus the word distribution of control but not data. It is considered in the autonomy. Then second one is a distribution, means actual distribution we have to consider. And third one is a heterogeneity. It may occur in various form in distributed system, ranging from hardware heterogeneity and different in networking protocol to variation in data manager. Then after DDBMS architecture, it is one of the client server architecture, means two-tier architecture, and we also known as a two-level architecture. Then after peer-to-peer, in which physical data organization on each machine may be and probably indifferent. This means that there need to be an individual internal schema definition at each site. Then it's work in a peer-to-peer. In a client server, there is one system work as a client and second system work as a server. At the time of requirement, this client server will communicate when client send the request to server, and based on that request, server will respond to client. And third one is a MDBMS. It's a nothing but a multi database system. So this is the DDBMS architecture, and it's a total hours given by the university in a syllabus is 3 hours, and total weightage of this unit is 7%. Now fourth one. Fourth unit name is a data distribution alternatives, in which first point is a design alternatives, in which 2 point localized data and distributed data. But two major strategies that have been identified for designing distributed database are the top-down approach and the bottom-up approach. We are designing our database in a top-down approach, means we have to start from the top position to bottom position, top to downwards. And in a bottom-up, based on the name, we all know that we have to start our procedure from the bottom to upwards or top level. Then the second name is a fragmentation. Fragmentation is nothing but a replication of your database. It's a different way to replicate your database. It's a vertical, it's a horizontal, hybrid, general guidelines and correctness rule. We have to learn in a concept of fragmentation. Then distribution transparency. Transparency means we have to make or we have to acquire the transparency with user. Means when user is accessing the data, at that time transparency must be needed. Transparency based on the location, fragmentation, replication, whatever. And then impact of distribution on user query, in which sub point is no global data dictionary, short form is GDD, and GDD contain location information. And we have to also understand the example of fragmentation. And total hour is allocated for this unit is 5 hour and weightage is 15%. So it's a much higher than other unit. It's a 50% weightage in our examination point of view. Then unit number 5, semantic data control. Here you have to understand the meaning of semantic. Semantic means conceptual. Here we are dealing or working with the logic or actual what the meaning of that data or database. We are dealing with that. First, again the point view management. View management again related with the ANSI Spark architecture, in which it is also similar name is a view architecture, conceptual architecture, because it's a unit name is also semantic data control. Then after authentication. Authentication, it's a name suggests we have to here work with the concept of security, because other person or unauthorized person cannot get the access of our database. So database authorization or operating system authorization or access rights, which person have to access how many portion of database, or it's a allowable or not, it's a authorized or not, such kind of things we have to learn in this point. And then after semantic integrity control, in which centralized and distributed both we have to learn. And cost of enforcing semantic integrity, whatever the cost we are going to face at the time of implementing this concept, that we have to study. Total hours allocated for this unit is 3 hours and weightage is 10% for the examination point of view. So it's all about unit 5, semantic data control. Then unit number 6, query processing, in which different point is query processing problem, layer of query processing in centralized system, parsing and translation, optimization, code generation is example, query processing in distributed system, mapping global query to local, optimization. Optimization is covered in both centralized as well as distributed. So what is the query processing? The main function of query processing or query processor is to transform a high level query into a equivalent lower level query. And the layer of query processing is query decomposition, then data localization, then global optimization, then local optimization, and after that optimized local query will be executed. So what happen when we are working in query processing, and what is the requirement of this unit? The query processing concept is used, or it's helpful to execute our query with low cost and low time. When we are executing any of the query in our application or on our database, at that time the main function or main the requirement of user is that they will retrieve fast result, as well as they can access that result at low cost. So the based on the concept of optimization, we can reduce the cost of query, as well as we can reduce the time of query. In a optimization, exactly what happen if we have two choice or multiple choice to execute the query, at that time with the help of optimization we are going to select that query which will use the low cost and low time to give us output. So in a query processing, whichever the query we are going to execute, the query will be executed properly and valid query that give you the valid or consistent output. Total hours allocated for this unit is 4 and weightage is 10%. So it's all about the unit number 6, query processing. Then unit 7, optimization of distributed query. So again the word optimization. So what is the optimization? Query optimization refers to the process of producing a query execution plan which represent an execution strategy for the query. The select plan minimizes an objective cost function. So this is the point, first query optimization. Then we have to understand centralized query optimization, then join ordering. Here the word join, all we know that what is the use of join. Join is used to merge two table, and when we are communicate or want to access the data of another table, at that time we can apply join. Then last one is a distributed query optimization algorithm. In that there are some of the algorithm which is related with the concept of distributed query optimization. This algorithm will be detailed shown when we understand or learn this unit 7, optimization of distributed query. Total hour allocation for this unit is 6 and the weightage of this unit is 10% for the theory examination. Then unit number 8, distributed transaction management and concurrency control. This entire unit is already basic introduction or basic concept we have learned in database management system. What is the concept of transaction? Why we are using that concept? That already discussed in or studied in database management system. The concept of transaction is used within the database domain as a basic unit of consistent and reliable computing. When any of the query or any of the function is executed from the database, at that time we can say that the transaction is executed, because based on that we are getting our output, in which the main property of transaction is acid property. Atomicity, consistency, isolation and durability. Based on that, the name is acid property cover up. Then after objective of transaction management, types of transaction, objective of distributed concurrency control, then concurrency control anomalies, method of concurrency control, serializability and recoverability. Serializability means we are going to execute our all transaction in a serial form, and recoverability work with when the transaction is failed at the time data must in a consistent state, so we can recover our data with the help of the concept of recoverability. Then distributed serializability, enhanced log based and time stamp based protocol which is used to perform our transaction effectively. Then multiple granularity, multi-version scheme, and last optimistic concurrency control techniques. The total hours of this unit is 8 and the weightage is 18% for the examination point of view. So in this unit we will discuss about the distributed transaction management and concurrency control, in which different concept of transaction, distributed transaction management, types of transaction, serializability, recoverability and some of the locking concept that will be covered up in this unit. And last unit is a unit number 9, distributed deadlock and recovery. Deadlock concept, deadlock in centralized system, then deadlock in distributed system. What do you mean by deadlock? All we know that when the process cannot step or work further, at that time we can say that the deadlock occur. So we have to detect it, then after we have to take prevention for that, we have to avoid it, we have to understand the algorithm, wait and die, wound wait algorithm. It's related with the deadlock, but we will discuss and that cover up with the distributed system. Then recovery in DBMS, in which types of failure we have to study, method to control failure, different technique to recoverability, write ahead logging protocol, then advanced recovery techniques, shadow patching. Shadow patching is already the topic of DBMS. Then fuzzy checkpoint, erase, then red level, two-phase and three-phase commit protocol. Two-phase we have learned in DBMS. Here we also have to understand three-phase commit protocol with two-phase. Then total hours given to this unit is 8 and weightage for theory point of view it's a 18%. So unit number 8 and unit number 9 both weightage is 18%. So it's a one of the most important unit, we can say that, as per our subject point of view. So it's the unit 9. In this we will cover up the concept of deadlock and recovery. Then what is the outcome of this course? After learning the course, you will able to understand what is distributed DBMS. You will understand various architecture of DDBMS. You will apply various fragmentation techniques for a given particular problem. Understand the step of query processing. how optimization techniques are applied to distributed database, learn and understand various query optimization algorithm, understand transaction management and compare various approaches to concurrency control in distributed database, and understand various algorithms and techniques for deadlock and recovery in distributed database. So this is the all about the introduction of our subject distributed database management system. That things we have to cover during this semester. And again, I request you all that if still you have doubt in database management system, and if you are not the clear with the basic fundamental of database management system, then I request you that please refer the basic fundamental of database management system, understand the basic query of the SQL like select, insert, update, delete, whatever the basic query which is used in SQL. So that what happen and what benefit will you get if you clear with basics of DBMS, then you will get better understanding and you will capture more directly in distributed database management system. So here we are concluding our lecture, and in our next lecture we will start our syllabus from the unit 1 introduction, and we will discuss about what is the actual distributed database management system. From the introduction point of view, we are taking one by one unit. I hope you clear about what you have to learn and what you have to do in distributed DBMS subject. Thank you for watching this video. Take care.